Hello folks, welcome to the channel. Today's video is in reference to Clough 42's YouTube electronic lead screw series. I'll put a link in the description. This video is going to focus on mounting the encoder portion of the ELS conversion. But first let's look at what an electronic lead screw does. First of all, the lead screw provides back and forth carriage movement. The lead screw turns in proportion to the spindle speed and is adjusted through the use of a gearbox and change gears. These gears adjustments allow for different carriage feed rates and determine the thread pitch when cutting threads. You can see the gearbox knobs at the lower left part of the lathe. These are the knobs with the arrows on them, and turning them provides different gear ratios. In addition, the lead screw is also adjusted by using change gears, which are visible on the left side of the lathe. Setting the correct feeds or thread pitch is a bit of a pain. You need to set the gearbox correctly and swap out the correct change gears. This process is time-consuming. This is where the electronic lead screw comes in. Rather than using gears, an encoder is used to read the spindle speed, and the lead screw is turned electronically using a stepper or servo motor. With ELS, feed rate or thread pitch changes are easily done using a digital display and buttons. Here we have the 3D printed parts, a belt, and some hardware. As mentioned, the model's hardware list and assembly instructions are available on Thingiverse. Before we assemble the mount, let's take a look at the encoder and why I decided to design a different mount. This is the recommended encoder, which I've already removed from the box. An encoder works by sending pulses when the shaft is rotated. Encoders are also smart enough to detect direction as well. What I found interesting is there was a coupler inside the box. This generally means the manufacturer wants the coupler used to keep any rotational forces away from the encoder mechanism. To put it simply, they don't want you hanging a pulley directly off the encoder. This is what I suspected anyway, and sure enough, it's listed as number 5 under precautions for correct use in the instructions. It reads, "Be careful not to apply excessive load to the shaft. Excessive load may cause the product to break, especially when linking with a chain, timing belt, or gears. Connect a separate bearing before coupling to the product." If we look back at the parts, we'll see 2 bearings which will be used on the driven pulley to isolate any forces. We'll use the coupler to attach the pulley shaft to the encoder as specified. The remaining parts are to provide belt adjustability and mounting to the lathe. For assembly, we first insert the 2 bearings. One goes in the slider plate, just snaps in there, and the other bearing goes in the mount. Next, we take the pulley and insert it into the slider bearing. Then we put the belt on the pulley. This is followed by attaching the mount using M4x14 button head cap screws. Now we attach the slider assembly to the base. We want to be sure the belt is pointed towards the spindle side of the mount, which is the curved portion of the base. This is the right way. The slider gets mounted by using M4 button head cap screws, washers, and nuts. I don't show it in the video, but it's important for the screws not to extend past the nuts. If the screws stick out too far, the slider won't be able to move when it's mounted to the lathe. Just use a few extra washers on each screw to keep them from sticking out too far. Now we can see how the slider moves on the base. Next up is the coupler. We want to hold the pulley upward as we press the coupler down. Then we use a 1.5 millimeter Allen wrench to tighten up the two set screws. Before attaching the standoff and encoder, we need to look at their positioning. You'll notice the standoff has a port on one side. This port is used to access the coupler set screws, so it's important that the standoff get positioned properly. This isn't hard. The port simply faces the side away from the spindle. The final thing to consider is the routing of the encoder cable. We want to position the encoder so its cable is sitting over the port. Both of these positions will keep the port accessible and the cable away from the spindle. We first mount the encoder to the standoff using 3 M3x10 button head cap screws. Next, we position the standoff over the mount. Since the encoder shaft has a flat spot, we want to turn the shaft so the flat isn't over the two set screws. Here I'm positioning the encoder and then tightening a set screw to hold it in place. Just tightening up the coupler set screws here. Well, that's about it for the assembly. You should be able to get an idea of how it works. In the next video, we'll look at mounting it to the lathe. So stay tuned for part 2. Oh, and we'll also see what that triangle piece is used for. Thanks for watching. Take care.